Okay, Honors Algebra 2, this is my third try on this video. Hopefully it will work. We are finishing our notes for matrices. I believe on Thursday we got about 1/3 of the way down page 7. So I think we got to here, which means right above here was the area of a triangle with, given the 3 points of the 3 vertices on the coordinate plane. And remember, the area is plus or minus 1/2 times the determinant. Remember, those straight lines mean the determinant. And you put in the coordinates of each point there, x, y, and then you put in a 1 for this whole third column. And the plus or minus just refers to sometimes the determinant can be positive, and then you'd use the positive 1/2. Sometimes the determinant is negative, so you use the negative 1/2. So I believe that we covered that on Thursday, so we are starting here with Kramer's rule. All right, so Kramer's rule gives us a method to solve a linear system. And so if you can remember, when we say system, we're talking about more than one equation. That's all that system means. So when you have a linear system, that means you have 2 or more equations of lines. Okay? So we are going to look at this linear system. I'm not sure why that bar is there, so you can get rid of that bar. Although I'm just making it orange, but I wish I could delete it, and we're going to make this equal to f. So we have these 2 equations, ax plus by equals e, and cx plus dy equals f. Now, when we have a linear system, so 2 equations, we can, from those 2 equations, write a coefficient matrix. And you can see how we did that. The coefficient matrix would be, these are the x coefficients, right? Ax and Cx, AC. And the second column would be the y coefficients, By and Dy, so right there. And then here's the constant matrix, EF. And so Kramer's rule says that you can find the solution to a linear system by using determinants. And so if you look, first thing you need to do is you need to find the determinant of the coefficient matrix. That's what this is right here, A, B, C, D. That is the coefficient matrix, but since it's solid lines, it's saying what's the determinant. So step 1 in using Kramer's rule is find the determinant of the coefficient matrix. All right, and then what you will do is for each variable, so in this case we only have 2, we have x and we have y, you are going to divide the determinant of the top matrix. Now, if you compare the coefficient matrix with this matrix, you can see that for the x values, we took out the x values here and we wrote in the constant values right there because we're solving for x. So if you're solving for x, you take out the x values and you put in the constant matrix values and you keep the b and d for y. But here when I'm solving for y, look at, I put back the x values, here's the x values, and I took out the y values, the b and the d, and here is the constant matrix because I'm solving for y. So the variable you're solving for, you take out their coefficients and you put in that constant matrix. And so you can see for x, you're going to do the determinant of the top matrix divided by the determinant of the coefficient matrix. And then for y, you do the determinant of the top matrix divided by the determinant of the coefficient matrix. So, I'm kind of bummed that there's all this writing here. I really would rather just do this with you. Is there any blank paper anywhere? You know what I can do? Maybe. Surely there's a way to bring up some blank paper. How could I don't know how. So we're just going to have to do it. Okay. All right, so here we are. We have an example. Let me get a different color going so my writing doesn't blend in. Let's try to ignore this stuff here except for just on how to. But the first thing I want to do is I want to write my coefficient matrix. But I'm going to use the straight lines because I actually want to find the determinant of it. And so I would have x coefficient is 1 for the top equation, 3 for the bottom equation. 7 is the coefficient for y, -5 is the coefficient for the bottom y. So now I want to find that value. And so since this is a 2 by 2, you won't use your calculator, so you do 1 times -5 minus 7 times 3. And so -5 minus 21, that gives me -26 as my determinant for the coefficient matrix. I'm going to be using that in each equation because you can see right here how we set that up. That is the denominator in both of these. And there's that 26 right there. Okay, so we've taken care of that. And so now what we're going to do is we're going to say x equals, and I'm going to divide each of these by that determinant. But for the top here, since I'm solving for x, I take out this and I put in this. So for x, I'm going to go -3, 17. The y's stay in there when I'm solving for x, so I have 7, -5. So find the determinant of that. So, -3 times -5 makes a +15 minus 17 times 7, which is 119 over -26. And so that then we can pick up right here or right here. So we get -104 over -26 and x is 4. So I know wherever these two lines go on my coordinate plane, they're going to cross at x equals 4. So that's, you would have an ordered pair where they cross. So the x value of my ordered pair is 4. And then I'm going to find my y value. And to find the y value, let me do it in another color. Okay, I'll say y equals. So I'm going to do a determinant. And again, I divide by the coefficient determinant, which is -26. So this time, since I'm solving for y, I use the x numbers, 1, 3, but instead of the y numbers, I take them out and I'm going to use the constant numbers, -3, 17. And so then I do 1 times 17 is 17 minus -3 times 3 is a -9. 17 plus 9 will give me, and that's divided by -26. So 17 plus 9 is 26 divided by -26, and I get a -1 for y. So I know then that these two lines cross at 4, -1. There's my answer. And I want you to give me the answers in ordered pair because these are lines on the coordinate plane and you need to give me the ordered pair where they intersect. You can see here that it says to check. So, just plug those in and make sure it works. Okay. Here, this is using a graphing calculator for determinants. We talked about this in class already. Here's your steps though. So if you don't remember how to do it, refer to that. And then here are the graphing calculator instructions on how to find the determinant of your matrix. And now we're going to do Cramer's rule with 3 equations. All right. And so step 1, we need the determinant of the coefficient matrix. So use your calculator to find this. So remember the coefficient matrix, you put in this first row, you're going to put all your x coefficients. So 1, -2, 3, 1, -2, 3. And then your y's are 3, -6, 5, 3, -6, 5. And then your z coefficients are -1, +1, -2. So there they are, -1, +1, -2. You, since this is a 3 by 3, you can use your calculator to find the determinant, and you will get a -4. So you should do that on your calculator right now. Make sure you can get that -4. And then moving on, step 2. To find x, you will replace the x column of the coefficient matrix with the constant matrix and solve using your calculator. So you can see right here, here is the x coefficients. Well, here, so to solve for x, we don't write those. These are the constant matrix, 1, -3, 4. So we take the x's out and we put in the constant, but look at the y's and the z's are exactly the same. And now you find the determinant of that matrix. And you get -8, and you're dividing by the coefficient matrix, which we already found was -4, and we'll get 2 for x. So then we do it again with y. And you should be doing these on your calculator to make sure you're getting the right numbers. So now we want to find y. So now when we do y, you can see right here, this was my y values, but those change here because I'm finding y. If I'm finding y, I take out these y values and I put in the constant matrix numbers right there. So the x values and the z values don't change, only the y values, because that's what I'm solving for. And I put the constants in, and I find the determinant of that, which is 0, divided by the coefficient determinant, and I'll get 0 for y. And then I do it again for z. So in this case, you can see this time it's the z values that have the constant matrix right here. The x values are good. The y values are good. I've only changed the z values because that's what I'm solving for. I do the determinant of that matrix, and I have -4 over -4, and I get 1. So the way I report my answer is x is 2, y is 0, z is 1. And that would be the answer. By the way, when you have z in your equation, you're dealing with a 3D coordinate plane, where x and y are just like normal. So you would have, y here, x here. But then you have this other axis that gives you the depth. So it's basically coming right back at you, but we kind of show it this way. It's coming through, coming right at you, and this would be the z-axis. So yeah, you don't have to graph it. You just need to know that that's your solution where your 3 lines intersect. Okay, so now we're going to do one on our own. Example 7, the Bermuda Triangle is an area located off the southeastern Atlantic coast. Find the area of the triangle on the map with coordinates. Okay, so this is an area of a triangle problem. We have our 3 points, point 1, which includes that, point 2, point 3. And so you can do that. Area equals plus or minus 1/2 times the determinant. And you would do the first point, x1, y1, and then a 1. And then the second point, x2, y2, and then a 1. And then the third point, which is all those lovely numbers, and you get x3, y3, and then a 1. And you put that in your calculator, you find the determinant, you divide it by 2, and make sure it's positive, and you'll have the area of the Bermuda Triangle. And there's your answer right there. But you should do this. You need to know how to use your calculator and find these. So give it a try and let me know if you can't get the right answer. Okay, so now here's 8. This is now a system of equations. We are going to use Kramer's rule to solve it. So the first thing we want to do is, and you should have your calculators out. I cannot show you my calculator right now, but I don't actually have the answer key to this, so we are going to be working on this together. So first do the coefficient matrix. So I have a 2, a 3, and a 5 for my x's. a 5, a -1, a -2 for my y's, and a 3, a 4, and a 7 for my z's. And I want to find the determinant of that. So I'm going to go into my calculator, edit my matrix. I'm just entering the matrix right now, as you should be at home. Okay, I have mine in. I'm going to find the determinant. So I go to math. First I want to quit. Always quit first, because otherwise it takes you to a weird place. And I have the determinant is -6. Okay, so now let me just check my numbers. 2, 5, 3, 3, -1, 4, 5, -2, 7. Okay, so the determinant is -6. And so now I'm going to want to find x. So what I do is I'm going to find the determinant, and using this matrix, I'm going to rewrite that matrix here, but for the x's, I take out the x's and I put in my constant matrix. So I'm going to go, since x comes first, I do 10, 8, 12. The y's stay the same, 5, -1, -2, and the z's stay the same, 3, 4, 7. And I need to find that determinant, and I will divide it by my coefficient determinant, which is -6. So let me do that on the calculator real quick. Okay, so now I do second function matrix, math, determinant, and I get a -42. Divided by a -6 gives me a 7. So x is 7. Now for y. Okay, so now since I'm going to find y, I'm taking out the y column right here and putting in the constant. So the x column is 2, 3, 5. The constants are 10, 8, and 12. And now I put the z's in, 3, 4, 7. And I want to find the determinant of that matrix, divided by -6. And so now I go back to my calculator, and I edit it again. All right, so now I do second matrix, math, second matrix, enter. I got -6. So I have -6 divided by -6, which is 1. Hopefully you are all getting the same numbers at me. You really should be doing this because my answer key is blank. I do not have answers here, so hopefully I'm not making mistakes. Okay, for z now. All right, so for z, I'm going to take out my z column and put in my constant. So the x's and the y's stay the same. So I do 2, 3, 5, 5, -1, -2, and then 10, 8, 12. And all that, of course, is divided by that -6 again. And so now I get to do it again, second matrix. And I know it's tedious, but think of how much worse it would be if you were doing these determinants by hand. So be thankful. Okay, so second matrix, math, determinant, and I got 18. Divided by -6 gives me a -3. And there you go. So that's my point. Now I want you to report it this way, remember, as a ordered triplet, 7, 1, -3. And there's my answer. Now, to check that, you can put that into each equation. You can mostly just do it mentally and make sure it works. But we're going to move on. Example 9, the salary for each of the stars of a new movie is $5 million, and the supporting actors each receive $1 million. The total amount spent for the salaries of the actors and actresses is $19 million. If the cast has 7 members, use Kramer's rule to find the number of stars in the movie. Okay, so for this one, we're going to say that X equals the number of stars. And Y equals the number of supporting actors. Okay? And we know, right here, there's 7 members. So we know one equation right there, X plus Y has to be 7. So we have one equation. And then the other equation would be based on the money. And we know that the salary for each star is $5 million. So however many stars there are, 5 times the number of stars, that would be the millions you spent on the stars, plus each supporting actress gets, or actor or whatever, gets 1 million. So 1 times Y equals the total they spent is 19. So there's our 2 equations. That's our system of equations right there. And so they say use Kramer's rule. So I'm going to write my coefficient matrix. And I have 1, 5, and 1, 1. That's my coefficient matrix. The determinant of that, since this is a 2 by 2, we're not using a calculator. So we go 1 times 1 is 1 minus 1 times 5 is 5. So we have -4. That's my determinant. Okay, so now to solve this, what's the question? Find the number of stars. So really, I only care about X. I mean, once I know X, I'll know Y, but X is what's important. So I'm going to say, okay, X equals the determinant. I take out of this matrix the X values, which were the first column, and I put in these. So I have 7, 19. The Y's stay the same, divided by the determinant of the coefficient matrix. So I need the determinant of that top matrix. 7 times 1 is 7, minus 1 times 19 is 19, over -4. So that gives me -12 over -4, and the answer is 3 stars, which means if I have 3 stars, I have 4 supporting actors. Okay, finally, question. In order to use Kramer's rule, what must be true about the determinant of the coefficient matrix, and why? Well, it can't be 0. Why can't it be 0? Because if it's 0, then I'm dividing by 0. I can't divide by 0, right? So we cannot have our coefficient matrix determinant be 0. And that's the end of the notes. Yeah, that's it.